Hi guys, and welcome to Ashton Tracy Horologist. Up today, we're going to be looking at a Seiko 6105-8119. We're going to be looking at the waterproofing resistance of these watches, and we're going to be looking at the crown rebuild, how we go about that, and what exactly that does. So here we have a beautiful Seiko 8119, Captain Willard, as it's known. Technically, the Willard was an 8110. Or 8110, sorry, but it's exactly the same watch, just produced for different markets, is what that last number means. So what we're going to do is we're going to have a look to see if this watch passes a pressure test. This is how the watch came in from the customer. So let's throw it in the pressure tester and see what happens. So we have a 3-bar setting on my electronic pressure tester, and we're going to throw the watch in, raise the table, and start the test. Now let's see what kind of results we get. The compressor's going to kick in. It's going to bring us up to our 3-bar needed. Now obviously this is a 200 meter water resistant watch, so 3-bar is only 30 meters. So you would think that for a watch like this, it should pass the test absolutely no problem. Well, let's see if that's the case. We have to wait a few minutes here while it does its thing. Now this machine works is, what it does is it pumps air into the watch, and if there's a leak in the watch, it measures the deformation of the crystal. And that's what that little sensor that we lowered down does in the watch there. It's the deformation of the crystal being measured. So we're going to wait to see if this watch passes a water resistance test. Now it has original gaskets, I'm assuming. I don't know when the watch was last serviced. I'm guessing no one's ever done a crown rebuild on it, and I'm guessing no one's changed the back gaskets. But might pass, might fail, who knows? Let's find out. Usually they fail. And we have a watch that has passed. Now, interesting. It's passed, but how long will it pass for? Well, it's good news that it's passed, and that would explain possibly why the dial is in such nice condition. But let's have a look at that gasket and check the condition. Well, we now have our case apart, and we can have a look at our gasket. Now, we can see that the gasket is pretty much on its last legs, but amazingly, it still passed a waterproof test. But there's no way that we want to put this gasket back in. It's just not going to be a good idea. And it's inevitably going to fail sooner rather than later. Now, we've got 5-year service intervals that I recommend with these watches. So, you know, putting this gasket in a couple months maybe, it's going to be touch and go, could leak instantly, and it's not going to give us any security. So we've definitely got to put a new back gasket in this watch. Now we get to our crown, and we need to look at our crown to see what kind of intervention it needs if we need to do a crown rebuild. Now, the easiest way to tell if we need to do a crown rebuild is to check the sponginess of the crown. Now I'll tell you, it's in there, and there's a little sponginess, but it is pretty stiff. So rebuilding this crown is definitely going to be the best option for this watch. So what do we do to rebuild a crown? What we do is we try and find the correct pin vise so that we can remove our stem, because our stem's just going to get in the way. We really need to get it out of the way. Let me just fix this camera. We really need to get our stem out of the way. So we're going to put our square in a pin vise, and we're going to unscrew it. Sorry about that. But before we unscrew, we're going to apply heat so we can break our Loctite bond. Now I'm going to do this off camera. Use the blue part of the flame. Heat it up to really get rid of that bond of the Loctite. Obviously cool it down before you touch it, but be careful not to get the stem in, because at that point what you're going to do is you're going to mess with the hardening and tempering of the stem. So you really just want to do the crown. Then we can turn and our stem is going to safely be removed. And we can see our stem is out. Seems to be the theme of the day. Now what do? Well, now we need to get the old gasket out of the watch, okay? The old gasket now has to be removed. Well, so far the best solution that's been found is to pack out the crown with smaller gaskets. Now what this does is we're going to fill the crown here, and we're going to push down these gaskets like this. Now I didn't come up with this. Some other genius came up with this. It's just something I do. It's important to note these are 1.7 by 0.6 gaskets is what we're using here. So for those of you that want to try it at home, 1.7 by 0.6. So we're at 3. At this point. Now they do really need to be pushed down. It can be quite difficult. Now what I like to do is I like to take a pusher from my Horrier set and actually force the gaskets down with the pusher. And the reason I use the pusher is because it really seems to fit in there perfectly. Now you're going to notice a bit of water. So we get the pusher and we push down. Now you're going to notice a bit of water in there. That's from when we submerged the crown so that we could kill the heat. Okay, so we've got about 6 gaskets in there now. Now these gaskets are most likely going to get ruined. So be prepared to order quite a few of them. So that you're able to successfully do this. Now what do? Well, now we need to go over to the vise. And we need to get ourselves a little plastic bag. The delicate art of watchmaking. Here we are at the vise. And what are we going to do? Well, we're going to put our push piece into the hole of our crown, and we're going to compress the gaskets down. Why do I call it the delicate art of watchmaking? Well, we're going to squeeze the crap out of it with a vise. Not something you'd normally do in watchmaking, but sometimes you need to squeeze it with a vise, sometimes you need to hit it with a hammer. That's the only way to get the job done sometimes. So in this situation, we're going to force the gaskets in, and they're actually going to push the bigger old gasket out up through, and we're going to take away and remove the inner, the washer that holds everything together. I should have prefaced this by saying the reason we're doing this is because we want to get rid of that washer. We want to bring that washer out without damaging it. Now what it's going to do is it's going to cone that washer out and bring it out as a cone. So we're going to turn our vise Turn our vise. And the chances that we actually get it out, well, it might not happen. And it has. All right, let's take it back to the bench. So here we go. Our washer has come out. And we can see our old gasket in here. Actually, before I remove this, I should have mentioned the reason we use plastic is to not damage the metal of the crown. If you are using a model that has any raised writing, you have to be extra careful, and you have to use something really soft, or even use a die or something that can hold around the crown without compressing on that writing. But here we have sunken, so we don't have an issue. So now what we can do is we can dig out this old gasket. And we just gotta muscle that bad boy out of there. There's the old gasket. And there are our smaller gaskets that we used to remove it. Dig those old ones out. Well, don't do that. But sometimes that happens. I'm not going to edit that out because warts and all, as they say. And then our inner ring can come out. Most likely we'll get it out in the ultrasonic tank. Now, why did we need to replace this gasket? Well, let's examine my 6105 Crown Gaskets. Now, these gaskets are a little big and they actually require turning down because I haven't found any replacements yet that are the exact size, and I haven't gone the route of having them made. Maybe at some point, but we'll see what happens. Gasket. Where's it get its waterproofing abilities from? Well, basically from being soft, from being rubber, compressed. Good waterproofing abilities. Tweezers are moving, not the gasket. So we can see that that gasket in there is way too hard. And that's never going to work. So what we need to do is we need to quickly turn down the diameter of our gasket here. Well, I personally like to turn them down on a lathe, but you probably don't have a lathe. So if you want to do this at home, so you can use some emery paper and put the gasket on something, and basically you just want to turning the gasket as you go to make sure that you don't make sure everything's even. You don't want to have, lower and higher spots on the gasket. So we now have our crown gasket turned to size that we need. It's a little bit oversized from the previous one, which is good, which is how I want it. And we can see that it's been turned down. Now I turned this down by hand. Now the reason I said before I use a lathe is because a lathe allows you to turn precisely and quickly, so you can cut down the outside diameter pretty quickly and evenly. You're not having any flat spots or higher spots. So I did this one though by hand to show you that it can be done if you don't have access to a lathe. You can turn it down by hand if you buy oversized gaskets. If you manage to find the correct size gasket, fantastic, use that. It is something I'm looking at having produced in the future, but at the moment I haven't found an economic, cost-effective solution for that. So this is how I do it. So we have our inner, this has been cleaned in the ultrasonic tank, nice and shiny now. So we have our inner piece in, and we can now fit our gasket in. And the best way to do that is to put it in place and pop it in with the back of the tweezers. For obvious reasons, we don't want to start poking our gasket with any sharp objects. We want to use blunt objects to push our gasket in. Now, before we go and fit our metal washer back, let's put it in the watch case and make sure that it rotates freely. Because if we've left our gasket too big, it's not going to rotate freely. So we can see that we've got some nice rotations there. So that's good. But we can feel that the gasket's engaging. We can feel that the gasket's actually doing something and causing the watch, making sure the watch is waterproof. Now, I mentioned previously that you wanted it to come out a cone shape. Now, that was actually a lie. You don't want it to come out a cone shape. I was getting confused. We need to make it a cone shape now so that the gasket can go back in. And for this, we use a staking set. We want to use a staking set where we use a rounded stake so that we can make a circular cone shape, and a lower hole that allows a cone to be made. So we now want to hit that with a hammer to force it out to make it like an umbrella so that we can get it back in and squeeze the washer back in. So we've now had our washer cone out like so that we can fit it. Now you are going to get a faint line or a faint ring on that washer. You can put some plastic down, but it's still going to damage it. It's still going to mark it slightly, and it's not a big deal. It's only just a surface marking, and it's not going to cause any problems. So now we can actually fit our cone into the washer, and hopefully we've made it enough of an umbrella, so to speak, to actually get it in. We can just tease it in place. And there we go. In place as it should be. But it's still obviously a cone shape, and it's not going to hold in place. So now we need to fix that issue. So here we have it set up in the lathe to tap it back. Now I like to use a plastic bag top and bottom so that we don't mark it. I'm not going to be able to do this on camera, but basically what we need to do is we need to flatten the cone shape, bring that cone shape again flat, so that that gasket or that washer holds the gasket in place. So I'm going to do that now, and then I'm going to show you the results once it's done. So there we have it. Our crown has successfully been rebuilt. Now again, we've got some small marks around the washer there. They are inevitable. They're going to happen. Anyone that tells you they're not, I'd like to see how they do it, because I don't believe it's possible. And I've even seen ones that other watchmakers have done, and they always generally bear those marks. Now, this washer, it needs to be as flat as you can get it. Again, it doesn't need to be perfect because its purpose is holding in the gasket. It doesn't actually have any waterproofing properties. So once we've got it flat, once we've got it in where it's seated should be, we know that everything is correct. So now we can put it in the watch and check the fit. So we got it in, push it on. Obviously it locks in place, but as well, it can be moved relatively freely. Then we want to add a little bit of fondant or silicone grease on there, and we're good to go. So now we can change out the crystal, change out the back gasket, pressure test it, and we should be pretty good to back to factory specifications for what this watch was able to do. So thanks for watching, guys. If you enjoyed this video, please subscribe to the channel. Please check out our Instagram at Ashton Tracy Horologist, and check out my website too, ashtontracy.ca. Thanks, and see you in the next video.